Every time fireworks explode in the sky, something magical happens. Colors bloom out of nowhere, sparks rain down dramatically, and everyone collectively goes, "Ooh!" Like we didn't see this coming. But here's the real question no one asks while craning their neck. What exactly just exploded up there? Because that wasn't magic, wishes, or sky confetti. It was chemistry doing a full Broadway performance. Fireworks look simple from the ground, but inside them is a tiny, carefully planned chaos bomb that somehow explodes perfectly, beautifully, and at the exact right moment. One wrong ingredient or one bad decision, and instead of a sky show, you get a cautionary tale. I'm Professor Everything, and today we'll be answering the question, what are fireworks made of? Right here on Explaining Everything. At their core, fireworks are tightly packed chemical systems designed to launch, explode, and glow on purpose. The main ingredients are fuel, oxygen-providing chemicals, metal compounds for color, and a structure that keeps everything from going rogue too early. Most aerial fireworks are built around a shell, which is usually round and wrapped in layers of paper. Inside that shell are small pellets called stars. These stars are the real performers because they're responsible for the colors, sparks, and patterns you see in the sky. Holding everything together is a casing strong enough to survive launch, but weak enough to burst apart right on cue. There's also black powder, a classic explosive mixture that provides lift and causes the shell to break open midair. A fuse connects all of this, burning at a carefully calculated speed so the firework explodes at its highest point instead of awkwardly halfway up like it forgot its lines. Every part exists for timing, control, and visual effect. Fireworks aren't random explosions. They're chemistry with a strict schedule. The launch starts with black powder, a mixture of potassium nitrate, charcoal, and sulfur. Potassium nitrate supplies oxygen, charcoal acts as fuel, and sulfur lowers the ignition temperature, so everything lights faster and louder. When ignited, black powder rapidly produces hot gases that expand violently, launching the firework into the air. Once the firework reaches its peak, a secondary charge ignites and breaks the shell apart. This explosion doesn't just destroy the firework, it releases the stars in all directions. Their arrangement inside the shell determines the shape of the explosion, which is why some fireworks form rings, spheres, or shapes that were definitely supposed to be hearts. As the stars burn, the real science show begins. Each star contains metal salts that emit specific colors when heated. Strontium produces red, sodium creates yellow, barium glows green, calcium gives orange, and copper produces blue. Blue is notoriously difficult because copper needs a very precise temperature. Too hot or too cool, and it refuses to cooperate, like a diva atom. Bright white flashes come from metals like aluminum or magnesium, which burn intensely and reflect light brilliantly. These metals are responsible for those blinding moments when your eyes briefly question their career choice. The entire process relies on perfect timing. If the fuse burns too fast or too slow, the explosion either happens too early or not at all. Fireworks succeed because chemistry, pressure, heat, and gravity all agree to behave. For once. Fireworks are incredibly sensitive to moisture, which is why humidity can affect how well they perform. Damp fireworks burn poorly, resulting in weak colors or sad little pops that feel emotionally disappointing. The paper casing isn't just cheap, it's intentional. The paper contains the pressure just long enough to build force, then tears apart cleanly, allowing the stars to spread evenly. Plastic or metal casings would completely ruin the effect and also terrify everyone nearby. Firework colors don't mix the way paint does. Instead of blending, each metal emits its own wavelength of light. That's why fireworks can show multiple colors at once without turning into a muddy mess. The crackling sound some fireworks make comes from tiny explosive grains that ignite rapidly in sequence. It's basically chemistry popping bubble wrap because it thinks it's funny. Despite the chaotic appearance of fireworks, their behavior is incredibly predictable when performed correctly. Every sparkle, whistle, and boom follows physical laws that have been tested, refined, and yelled at by scientists for centuries. Fireworks are made of paper shells, black powder, carefully arranged stars, metal salts for color, and fuses that control timing down to the second. They're not magic. They are precision-engineered chemical reactions designed to explode beautifully instead of disastrously. Every firework is a tiny agreement between science and chaos, where heat excites atoms, pressure launches shells skyward, and chemistry paints the night sky in color. It's loud, flashy proof that science doesn't have to be quiet to be brilliant. And now, the next time fireworks light up the sky, you won't just see colors. You'll know exactly what's burning, exploding, and glowing up there on purpose. Before the smoke clears and the last spark fades, make sure to like this video and subscribe for more explosions of knowledge that won't require safety goggles. If you enjoyed uncovering the chemistry behind fireworks and want more everyday science explained in a fun, no confusion way, you're in the right place. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other bingeable channels. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.